My name is Henk Brans, and I work as a researcher and advisor in the Netherlands Institute for Public Safety and mainly on electric vehicles and battery fires. So today I'm going to present about the experiment that we performed on the full battery electric vehicle. And we tested the ultra high pressure extinguishing system. Maybe you may know it as the Cobra cold cut system or cool fire system in order to stabilize the battery pack once thermal runaway started in the electric vehicle. So uh, what is the background? So in 2023, a Swedish study was published on various extinguishing agents to extinguish the battery fire, which some pictures are shown here and there. They did some testing on the battery pack of the vehicle, as well as on a full electric vehicle with the Cobra system. However, they were not allowed to share the images or any more detailed information on the test by the supplier of the vehicle, by the manufacturer. And we wanted to explore this method for our Netherlands fire context. So what we actually did, we found contact with a vehicle supplier who wanted to donate us two of the full electric vehicles. And we performed some tryouts there on site and started to prepare the experiment. So what was the plan? Actually, we wanted to make a cooperation between the public parties, the local fire brigades and suppliers from all over the Netherlands, because we not only wanted to perform the fire test, but also make preparations on instructions for how to use this Cobra, this ultra high pressure extinguishing system in the Netherlands. So we needed to make like the national working group. And we really had three main topics that we wanted to address because in the Swedish study, it was actually demonstrated that penetrating water inside the battery pack is effective in stopping the thermal runaway, or actually more precisely, the thermal propagation from cell to cell of thermal runaway. What we wanted to do is make sure that if we do this the setup of this Cobra system, it needs to be safe, effective, and also practical applicability by the Netherlands Fire Service. So we had the two test vehicles with 75 kilowatt hours full electric vehicle, and we had it on 100% state of charge. And we made like some preparations, like we cut the tires, we made them empty to avoid explosion of the tires. And we also opened the windows to mitigate the explosion risk of accumulated flammable gases that may arise. So we want to mimic actually the real case with our fire test. So what we did in the Netherlands, you should understand this ultra high pressure system is not standard on fire trucks. There are about 20 specialized fire trucks spread in the Netherlands who have access to this ultra high pressure system. So when the vehicle fire happens on the street, it's more likely that a regular fire truck will be at the location more quickly. So what we did is make the procedure that we first extinguish the vehicle body, so and the seats and the interior fire. Also because the heat release rate of the vehicle body is actually more intense than of the battery pack. And once the vehicle body fire was extinguished, the leader of the fire group of the regular fire truck decides whether the battery pack is involved or not. If the battery pack is involved, he can decide to call the ultra high pressure team in order to stabilize the battery pack. And I must say that actually now we have three methods. So using the ultra high system, we also have like the submersion container in which we submerge the car into water. And if the situation is like okay enough to let it burn down, we also can do that. And actually, that is the preferred method. If there is enough space, like in the countryside, for example, we may actually prefer to burn the vehicle down and let it burn out, because in that way we are sure that we have no pollution of water and the battery will be consumed by the fire as much as possible. But this procedure is more like in the place where we are not able to let the vehicle burn down. So we have like another tool in the toolkit. So now I want you to tell how did we initiate the thermal runaway in the battery pack, because it was really important that we succeed in initiating the thermal runaway and it is safe for the fire crew who will deploy it. So for this, we did the mechanical damage by penetration. So we penetrated the battery cell in order to start thermal runaway, which generates heat and the thermal runaway reaction. So what are advantages is that you can actually try multiple times. If you penetrate and you miss the battery cell, you can try again, and we have immediate result. So actually, when we penetrate, we will see the battery thermal runaway start like in within seconds or instantaneously, which is quite practical in the experimental setup. And you somehow know what is the location where you start the thermal runaway. Some disadvantages, you make some damage to the battery pack, and you need to be aware that the jet fire can come out quite unexpectedly. So, and then sometimes the battery pack is a bit difficult to reach, but we all could handle that. So I show you here how we actually performed the penetration, because it is like a test and we had a drill on a standard and then we had this rope in which we could like lower the drill without being too close. So even if the jet fire comes out unexpectedly, it could be safe because we are having the operator on quite some distance. So this is what we actually designed to penetrate the battery pack. So this is not the real vehicle. This is of course just to make the construction. And actually we succeeded with this procedure. So, and also why we did this is because we do not have to make any preparation to the battery pack. We do not need to open it because we actually in our fire station, we had no equipment to make preparations or make like the heater in the battery pack. So this procedure allowed to initiate thermal runaway without opening the battery pack. So that's why we designed this. So then the most important thing for me is how can we guarantee safety of the fire crew when we are going to make the penetration with the Cobra system on the battery pack, because until now we often have said to our fire crew we do not want the firemen to approach the burning electric vehicle battery really closely because we have unexpected jet fires as well as toxic and flammable gases. However, now we at the end wanted to do this. So what I did, thought we thought about all the hazards that are possible and make a countermeasure in order to in order to uh, have some safety measure for this. So for these jet fires, we had like a backup low pressure jet of water. So when like an unexpected jet fire comes out of the battery pack, we have a backup fireman or firewoman who can make a water stream directly to protect the operator of the Cobra. And if possible, we do not want to make approach towards the pressure relief valves of the battery pack. So for the explosion of flammable gases that accumulate from the battery pack, we make sure that we have open windows and doors, and we only approach the vehicle if we observe ignition of the gas, which means that we have an ignition, so we could not have the explosion risk anymore. For the toxic gases, We have the breathing apparatus and personal protective equipment, which should be enough for this. And for electrocution risk, together with a local fire station, they formed some conductivity tests, like with the Cobra system, and as well as with water and a voltage source. And some results of this electrical conductivity test I will show you now. And the conclusion is actually that although it may seem dangerous, in theory, by the measurements, we will not have any, it's not likely to have electrocution when penetrating with the ultra high pressure system into the battery pack. And I will explain you why. Because here on the left side, we have the regular situation if we have penetrate with the pressure system onto the battery pack. So like the water is this dotted line. We have like high resistance of the handle of the ultra high pressure system, which is about 5 million ohms. And we have a floating current network because in the normal circumstances, the battery pack is not connected to the ground. So we have no closed current circuit. So actually we have a double protection against the risk of electrocution because we have a proper insulated handle of the ultra high pressure system and as well the battery pack making no contact to the ground. If in the right scenario, the operator may lose grip and accidentally touch the metal part of the ultra high pressure system, then we still have no electrocution because the battery pack is not making the closed circuit, current circuit. In theory, it can be possible if like there is some damage to the battery pack and making contact with water, and the shoes or the feet of the operator are also in contact with water, and he touched the metal part, then the resistance of the water jet is about 2 to 5 kilo ohm, which in theory may induce a current through the operator. But in this situation, we should have like three failures. Failure of the the operator touching the metal part, the battery pack being damaged, and touching like a big puddle of water, both touching operator and battery pack. It is unlikely, but in theory, this would be the possible scenario in which we can have an electrocution risk. However, it should be noted that the operator will also have like regular gloves, not the electric gloves, because it's not possible to wear both electrical and fire insulating gloves. But we think this risk is really unlikely, so we have no extra precaution for electrocution in our procedure. Then I wanted to tell you how do we manage or observe the thermal runaway during the experiment, because we did not want to make like dependent on advanced measurements. Why? Because the fireman in the street needs to be able to observe thermal runaway himself. So that's why we make these four definitions, which can determine the state of the battery pack based on visual effects as well as the thermal imaging camera, which are always on site of the fire truck. So first we make the observation, the fire officer thermal runaway is in effect. And how he does it is that after the extinguishment of the vehicle body, he observes the smoke and flames from battery pack, as well as the popping sounds or hissing sounds from popping battery cells. And in the thermal imaging camera, he can see hotspots on the battery pack. Then, if we decide we make the operation with the ultra high pressure system, we penetrate the water into battery pack on the hotspot. Then we say the battery pack is being cooled and we observe the formation of steam from water into steam, and that makes that the battery pack is being cooled because of the water being converted to steam. Then we say that the deployment is effective if the steam formation stops and we see the leaking water from the battery pack, because that will indicate that there is no there's no transformation from water to steam anymore and that the battery pack has cooled sufficiently. And then on the thermal imaging camera, we should see no hotspots on the battery pack anymore. We can say to terminate the deployment if we have no visual smoke, no visual flames, and no hotspot after 4 to 5 minutes. And actually, the MSB in Sweden said 15 to 20 minutes, but to be sure for the experiment, we make a time frame of 45 minutes to be sure, and with the monitoring on the background. And in that 45 minutes, we did not see the reignition. And at the end, we will advise 30 minutes to our fire crews as sufficient for this monitoring period. So before the big fire test, we had some fire training by Cold Cut Systems. They came over to us and make some briefing because this company of the ultra high pressure system already is making some experience by using the system on the electric vehicle battery pack. So they instructed all our fire crew members for the experiment. And here I show you what we did on the experiment day itself. So actually this was on the Amsterdam airport fire site, the fire training location. And here we had the vehicle and we had the vehicle and the ultra high pressure unit on the left and the regular fire unit on the right. And we marked some zones in which you need to have breathing apparatus or in which you're not allowed to go in order to guarantee safety of everyone on site. Now I'm going to show you some pictures to give an impression of the experiment. So here we have our drilling setup in which I told you about. We properly prepared it to make sure it will hit the battery pack. Then here you can see the fire officer pulling the rope so that the drill will lower and initiate thermal runaway by mechanical penetration. And then here you can see the jet fire resulting from the penetration of the battery cells. Then we have 10 minutes in which we let the fire develop into the full vehicle fire, battery electric vehicle. And then after 10 to 12 minutes, the regular fire truck will make sure to extinguish the vehicle body with the low pressure jets. So in this stage, the vehicle body was extinguished and we now only see the jet fires coming from the battery pack. So this will be the moment that the fire service will transfer from the regular fire truck to the specialized ultra high pressure fire truck. So here they are preparing the ultra high pressure system. Here we have like the thermal imaging camera looking and deciding where is the hotspot in the battery pack. And also we are starting to make the backup water jet, low pressure water jet in preparation. So here's some discussion where will we penetrate the ultra high pressure system. And here we also place the ventilator in order to all the gas and the steam which will come to make it as much away from the operator as possible. So here we approach and we have, as you see on the left, the backup water jet for protection of the operator for unexpected jet flames. And then here we penetrate the battery pack on the hotspot. And actually, this is quite a heavy duty for the operator because he has to be in this position for 2 or 3 minutes straight because the hole is quite small and he needs to hold the handle on the same place. So this is actually quite exhausting for the operator, this procedure, because he needs to do this for 2 or 3 minutes. So this is something we should consider. And here you can see that there's a couple, one having the thermal imaging camera, in which you can see the hotspot of the battery pack, and we have the operator, which makes sure he is on the hotspot and penetrates the water. And that goes on, yeah, for a few minutes because the water needs to be put into the battery pack maybe 2, 3, 4 minutes. And after he finished the first hotspot, if there are remaining hotspots, he should go to the next hotspot. So this can take quite a while actually. It's not, you stabilize the battery pack at the end, but it's not like a quick fix. You need to take time for this procedure. It took us maybe 1 hour in total, like 10, 15 minutes, the regular fire truck making the vehicle body stay, and about 40 minutes, 45 minutes for this whole Cobra procedure. So you need to take time for this. It's not something you can finish really quickly, but you will stabilize the battery pack in the best event at the end. And here you can see, yeah, like what is happening here. We are cooling the battery pack, and we're having for safety, the backup cooling of the battery pack and avoiding jet fires coming into the operator. We also collected the water in order to avoid pollution of the site, and we also did some water analysis in which we see that their water will be highly contaminated with heavy metals like nickel, manganese, and cobalt if you have the NMC battery. So this, if you are in an area which needs to be protected from pollution of water, it is also something you should consider when using this method, that you will generate contaminated water with metals from the battery pack. So this is also something you should take into consideration. Well, if you want to see some video, we have like some video material on our YouTube channel in English subtitles, where we will show the fire experiment. So I think Rukesh will share this slide so you can watch in your office when you have time for this, if you like. So what is our conclusion for safety? Actually, the measures that we made up in the beginning, for the flames and jet fires, we need to have correct position of the operator, and we always have these low pressure water jets for protection. For explosion, we separately tested that you can use the ultra high pressure system also to break the windows, as shown in this video. So if you cannot open the windows, or the windows are not opened, you first make sure to open windows by breaking them with the ultra high pressure system. So you exclude the explosion risk and you ventilate the flammable gases. So for the toxic gases, we have just the regular personal protective equipment, which is okay. And for electrocution risk, I show you that it is really unlikely in this procedure. For effectivity, we should start the deployment of the pressure system on the biggest hotspots if it's safe. The duration of water, we can see the steam formation and the transformation from steam to leaking water as indicators whether the injection of water is successful and when it can be terminated. And we say the battery pack is stabilized if we have no more hotspots on the thermal imaging camera and thermal runaway has stopped. Sometimes you may see like a little vapor or little smoke from the water that is still a little bit warm. So yeah, you should be careful in monitoring that before you decide if the thermal runaway has stopped. And we also did some interview with the fire crew, and actually they felt pretty safe during the deployment, and it was relatively easy for them to deploy. However, some learning points for them are the communication because of a lot of noise and because it's pretty crowded around the vehicle, visibility was a bit difficult. And they noted the fire duration was longer than they expected. So they needed to cool down multiple hotspots, which is quite exhausting for the operator. And it's a bit cramped because you need to operate the cooling of the backup water jet. So that was also a little bit difficult to be around one vehicle. However, in conclusion, we stated for our fire crews that they may use the ultra high pressure system in the Netherlands for cooling down and extinguishing the battery pack of electric vehicles. And it is now already being used in several cases in the country. And for this, we made some training material which can be used, and we translate it also in English. So this is on our website. On the left, we have the instruction how to use it, and on the right, the research report in which we have the research which I presented to you in the document. So this for now is my presentation. So if there are any questions, please ask. And thank you for letting me join you.